Hello, this is TCG and welcome to the ninth lecture for the CompTIA Security Plus 601 exam. Let's get started. Mobile networks. Point to point or P2P. Point to point networks connect two devices directly. They are used in scenarios where a direct high speed link is required, such as connecting two buildings with a microwave link. They provide low latency and high reliability. Point to multipoint or P2MP. In a P2MP configuration, one central device is connected to many endpoint devices. It is common in wireless internet service providers or WISPs and network distribution within a campus. It ensures secure communication between all points to prevent interception and unauthorized access. Cellular network. Cellular networks provide wide area wireless communication through a network of cell towers. They offer extensive coverage and high mobility support. Vulnerabilities of a cellular tower include interception of communication, tracking of user location, and potential exploitation of network infrastructure weakness. Wi Fi or wireless fidelity. It is very commonly used in home and business networks, and some of the risks to Wi Fi include unauthorized access, man in the middle attacks, and weak encryption. Bluetooth. Bluetooth can help us connect wireless peripherals such as headsets and keyboards to our PCs. It can also be used to transfer files between devices. It consumes low power and is easy to use. Bluetooth is vulnerable to eavesdropping, bluejacking, and blue snuffing. RFID or radio frequency identification. RFID uses electromagnetic fields to automatically identify and track tags attached to objects. Vulnerabilities shown by RFID are unauthorized reading, cloning of tags, and relay attacks. NFC or near field communication. This technology enables two electronic devices to communicate while in proximity. It is used for contactless payments, identification, and data exchange between devices. NFC is vulnerable to eavesdropping, data corruption, and relay attacks. Infrared or IR. IR is often used in remote controls where we need short range data transfer with low interference. Infrared also requires physical proximity with the device. USB or Universal Serial Bus. USB devices are used now every day nowadays, from data transfer to device charging to peripheral connectivity. USBs are also used to transfer malware, gain unauthorized data access, and do physical damage to devices. GPS or Global Positioning System. GPS is a satellite based navigation system which offers wide coverage and high accuracy. It requires data and connectivity from at least three satellites at a time. GPS can also use Wi Fi and cellular towers to determine the location of the device. Mobile Device Management or MDM. Mobile devices are endpoints that can be a point of vulnerability or a security leak, which is why we need a security, monitoring, and management of these mobile devices. This is where MDM comes in play. Application Management. An enterprise app store contains applications that have been verified by the organization. Blacklisting refers to blocking certain applications and services, while whitelisting is the opposite. That means that it only allows certain applications and services to work on the device. App wrapping refers to securing an application by isolating it from other applications. Lastly, updates and patches are rolled out by the organization after testing. Mobile Content Management or MCM. MCM controls access to and distribution of corporate content on mobile devices. It provides a secure way to distribute documents and media. It implements policies to restrict who can access certain type of content and encrypts data in transit and data at rest. Remote wipe. Remote wipe allows administrators to remotely delete all data on a mobile device. It is useful in situations where a device is lost, stolen, or hacked. The wipe can be of two types, the full wipe and selective wipe. Full wipe deletes all data, returning the device to factory settings, while selective wipe deletes only the corporate data, leaving personal data intact. Geolocation and geofencing. Geolocation uses GPS and network based methods to determine the physical location of a device. Geolocation allows for functions such as asset tracking, locating lost devices, and ensuring compliance with geographical policies, but is also a concern for privacy, which is why we use geofencing. Geofencing creates a virtual boundary around a physical location to trigger actions when the device enters or exits this boundary. For example, a device may be automatically locked or alerts may be triggered when the device leaves a designated area. Screen lock. Screen lock prevents unauthorized access to the device and its data. Screen lock is secured using passwords, pins, patterns, or biometrics, which may include fingerprint or facial recognition. Push notification services. Push notification service allows administrators to send alerts and messages to devices. These notifications may show sensitive information, which is why they are controlled by the MDM. Passwords and pins. Passwords and pins are fundamental for authenticating users and securing devices. Passwords need to be strong, so MDM can be used to enforce strong password policies. And most devices implement a lockout or a wipe mechanism after a set number of failed attempts. Biometrics. Biometrics provide an additional layer of security through unique physical attributes. It can use fingerprint, facial recognition, or iris scan. It is convenient and secure. Context aware authentication. This kind of authentication takes multiple factors such as location, time of day, network connection, and device state into account for authenticating. It can also be used to increase security measures where unusual or high risk context are detected. Containerization. Containerization refers to separating personal data and corporate data. In this case, we create a distinct work profile on the device. Full device encryption. All the data is converted into a secure format that can only be unlocked with the correct credentials. It is often required by regulatory standards and corporate policies. Mobile device security. Micro SD HSM or Micro SD hardware security module. It is a small module that fits into the micro SD slot and provides secure storage for cryptographic keys and also performs cryptographic operations. It is isolated from the main device hardware and software, so any attacks to the device do not affect the module. Unified Endpoint Management or UEM. UEM integrates the management of all endpoints, including mobile devices, desktops, laptops, and IoT devices, onto a single platform. Using a UEM simplifies the management process, improves security posture, and ensures consistent policy enforcement across all devices. Mobile Application Management or MAM. MAM focus on provisioning, updating, and removing applications on a mobile device. It can come with an enterprise app store and allows administrators to deploy, update, and remove applications remotely. SE Android or Security Enhanced Android. SE Android is a security enhancement for the Android operating system, providing mandatory access control or MAC policies to enforce strict access controls and improve overall security. It ensures that the system services or daemons run with the least privilege necessary and all the applications are run in isolated environments. Nowadays, SE Android is a part of the default Android operating system. Mobile device enforcement. Third-party app store. It refers to an application marketplace other than the official one. Using third-party app store has a higher risk of downloading applications with malware. MAM allows us to control this by whitelisting or blacklisting applications. Routing or jailbreaking. Routing or jailbreaking refers to gaining root access on Android or iOS devices, respectively, bypassing manufacturer restrictions and security policies set by the organization. It also increases exposure to malware and exploits. MDM allows us to detect and block rooted or jailbroken devices. Carrier unlocking. Smartphones that we buy through our carriers are carrier locked. This carrier lock stops us from using other carriers. Carrier unlocking exposes our device to less secure networks, which is why MDM policies restrict carrier changes and monitor network connections. Firmware OTA or over the air updates. Over the air update refers to remote updates to a device's firmware. This has the potential for malicious firmware updates and issues with untested or unstable updates, which is why the organization may test these updates and send out these controlled updates to manage and approve OT updates through the MDM. Camera. Attackers can use camera on a mobile phone to gain unauthorized information on a facility, which is why we use MDM to enable or disable camera use based on location. SSS and MMS. Both SMS and MMS can be used for phishing attacks. MDM can restrict use of SMS or MMS or enable it on certain conditions such as the time of day. External media. External media involves USB drives, SD cards, and other removable storage devices that can carry risk of malware infection and data theft. MDM can restrict or disable the use of external media. USB OTG or USB on the go. It allows mobile devices to act as a host for other USB devices. It has a risk of transferring malware via external media and unauthorized copying of sensitive data. MDM can monitor and control connected USB devices. Audio recording. Audio recording in certain places can be a violation of someone's privacy and can leak data, which is why we can disable audio recording in sensitive areas. Geotagging or GPS tagging. All files have something called metadata. Metadata can contain information such as the geographic location of the device. Whenever we take a photo, location information is embedded on the metadata of the photo. MDM can disable geotagging for sensitive applications. Wi-Fi direct or ad hoc. Wi-Fi direct enables peer-to-peer connections between devices. It does not use a traditional network, but has potential for data interception, leakage, and can potentially introduce vulnerabilities. Hotspot or tethering. Hotspot or tethering allows a mobile device to share its internet connection with other devices. It can allow outsiders to attack the device on the network. We can track and control hotspot usage through MDM. Payment. We can use mobile devices for payments via NFC, mobile wallets, and payments. In the recent years, this has given rise to fraudulent transactions, which is why we use the standards set by companies and the government. Mobile deployment models. BYOD or bring your own device. This refers to using and bringing their own personal device for work. Since there can be a large variety of devices, all of them can be very difficult to secure. COPE or corporately owned and personally enabled. These devices are company owned that can also be used for personal purposes. The company retains ownership and can install necessary security softwares, enforcing policies and manage the device. These devices can also be used on a personal basis. CYOD or choose your own device. In this one, employees can choose from a list of pre-approved devices provided by the company. This gives the employees some flexibility on what they want. Corporate owned. These devices are fully owned and managed by the company with no personal use allowed. It is easier to ensure compliance with regulations and policies in this model. Employees often keep a second phone as a private phone. Virtual desktop infrastructure or virtual mobile infrastructure. VDI and VMI involve using virtual environments to access corporate resources on mobile devices. This allows employees to access corporate resources from any device and from anywhere. It is cost effective, flexible, and secure. Cloud security controls. High availability minimizes downtime and ensures continuous operation by eliminating single points of failure. Availability zones are physically separate data centers within a cloud provider's region. Provide fault tolerance, and reduce the risk of data loss. Having high availability means also having load balancing to distribute network or application traffic across multiple servers. It prevents overloading and redirects if servers are down. Resource policies. These policies govern the allocation, management, and security of cloud resources. It includes enforcing least privilege access and ensuring compliance. IAM or Identity and Access Management. IAM is used to manage user identities and their access to resources. RBAC or Role Based Access Control. RBAC assigns permission based on user roles within the organization. Secrets management. These secrets may include passwords, API keys, and encryption keys. Some cloud service providers offer centralized storage solutions for managing these secrets, such as AWS Secret Manager, Azure Key Vaults, and more. These secrets are encrypted both in transit and at rest to ensure data confidentiality. Strict access control is implemented to limit who can access and manage these secrets. Integration and auditing. Information and auditing involves collecting and analyzing security data to monitor cloud environment and ensure compliance. Security, information, and event management or SAME. SAME is a solution that provides real-time analysis of security alerts generated by applications, network hardware, and other systems. It gathers logs from various locations such as applications, network devices, and cloud services to identify patterns and anomalies and generate alerts accordingly. Securing cloud storage. Redundancy. Redundancy involves storing data on remote servers managed by a cloud service provider. It enhances data availability and reliability, ensuring data remains accessible even if one copy is lost or corrupted. Access to sensitive information. It involves controlling who can view or modify sensitive data stored in the cloud. The purpose of this is to protect sensitive information from unauthorized access and potential data breaches. To do so, we implement strong access controls and regularly review access permissions. Permissions are policies and rules that define user access levels to cloud storage resources. To implement these permissions, we use IAM roles, role-based access control, and policy-based access control. Encryption. Encryption ensures data is unreadable to unauthorized users by converting it into a coded format. The data is encrypted before it is uploaded to the cloud and is encrypted once it reaches the cloud service provider's servers. We also need to make sure that the encryption keys are securely stored and managed. Use managed key services, implement key rotation policies, and apply access control for the same. Replication. Replication can help us in disaster recovery by ensuring that data can be recovered in case of a disaster or a data loss event and will minimize downtime and data loss, maintaining business continuity. We use replicated data for analysis without affecting the primary data set. We also create copies of data to protect against accident deletion, corruption, or ransomware attacks as backup. Securing cloud networks. Cloud networks. Cloud networks are networks created and managed within a cloud environment to connect various cloud services and resources. It is the underlying infrastructure for cloud computing. Virtual networks. Virtual networks or VNets are logically isolated in the cloud environment. They allow us to isolate and secure cloud resources, control traffic flow, and establish secure communication channels. Public and private subnets. Public subnets are subnets that allow resources to be accessible from the internet. They host resources that need to be communicated with external clients. Private subnets are subnets that restrict access to the internal resources only. It protects sensitive resources from direct internet exposure. Hybrid subnets are subnets that allow some resources to be accessible from the internet and restricts others to internal access and other resources. Segmentation. Segmentation refers to dividing a network into smaller, isolated sections in order to limit the scope of potential security breaches, manage traffic more efficiently. We use VLANs or VPCs for the same. API inspection and integration. It ensures that APIs used in a cloud environment are securely and properly integrated. It monitors and analyzes API traffic to detect and prevent malicious activities. It is done by API gateways, web access firewalls, and rate limiting. It ensures secure and seamless communication between different cloud services and applications via API. It also allows for authentication and authorization, encryption, and monitor and logging. Securing compute clouds. Compute Cloud is a service which offers virtual machines or VMs, containers, and serverless services for computing. They allow users to run applications, perform computations, and manage workloads without the need for physical hardware. For example, the Amazon Web Services EC2, Azure VMs, and Google Compute Engine. Security groups. Security groups act as virtual firewalls to control inbound and outbound traffic to and from compute resources. They control traffic based on the transport layer protocol and the network layer protocols. Dynamic resource management. Dynamic resource management involves adjusting computing resources based on demand to ensure optimal performance and security. By limiting idle resources, the organizations pay for nothing more than what they use. Instance awareness. Instance awareness refers to monitoring and managing individual compute instances. It inspects data that is being used, the inflow and the outflow. It also allows us to enforce policies. VPC gateway endpoint. VPC gateway endpoints provide secure and private connectivity between a VPC and supported services without using the internet. For using VPC gateway endpoints, we need to set up VPC gateways, endpoints for services like S3 and Dynamo database. Container security. Containers are lightweight and portable units that package application code and its dependencies. To secure containers, use trusted base images, scan the images for vulnerabilities, and sign images for the integrity. Isolate the container from other applications and implement security policies for container runtime. Cloud Security Solutions. Cloud Access Security Broker or CASB. CASB is a security policy enforcement point placed between cloud services consumers and providers to enforce enterprise security policies. It can be cloud based or on premises. It provides insight into the cloud application usage, ensure adherence to regulatory requirements, protects sensitive data through encryption, tokenization, and data loss prevention, and detects and mitigates threats like malware and compromised accounts. Application security. Application security in the cloud involves securing applications throughout the life cycle from development to deployment and operation. It involves securing coding practices, static application security test, dynamic application security test, runtime application self protection, and web application firewalls. Next Generation Secure Web Gateway or SWG. An SWG is a cloud based or on premises solution that provides secure internet access by inspecting and controlling the web traffic. An SWG is instance aware, examines APIs, inspects HTTP traffic, and detects and blocks malware, phishing, and other web based threats. Firewalls in the cloud. These firewalls provide security for cloud infrastructure by monitoring and controlling incoming and outgoing network traffic. They can be a virtual appliance or a cloud native service. It comes in two types: network based firewalls and host based firewalls. It allows filtering in level 3 and level 4, gives more granular control in level 7, identifies and blocks malicious traffic, and integrates seamlessly with the cloud. Security controls. Controls refer to the policies, procedures, and technologies used to protect cloud infrastructure, applications, and data. These controls can be preventive, detective, and corrective. Preventive controls measure to prevent security incidents. Detective controls measure to detect security incidents, while corrective controls measure to respond to and recover from security incidents. These controls can be cloud native or can come from third party solutions. Identity controls. Identity provider or IDP. The IDP manages user identities and provides authentication services. Single sign-on or SSO. SSO allows users to log in once and gain access to multiple applications without re-authenticating. Attributes of identity control. Attributes are information about a user and hence can be used for authentication. These attributes can be basic attributes, role-based attributes, or custom attributes. Certificates. Certificates are digital documents that use public key infrastructure or PKI to authenticate. These certificates are verified by a Trusted Certificate Authority or CA. Tokens and cards. Smart cards. Smart cards are physical cards with embedded chips that store authentication credentials. Tokens are digital objects that represent the identity of a user and provide access to resources. These tokens may be stored in the USB. SSH keys. SSH keys are a pair of cryptographic keys, public and private, used for authenticating and securing SSH connections. The private key is kept secret and used to sign authentication requests, while the public key is shared with the server and used to verify the signature. SSH key based authentication. SSH key based authentication refers to logging in into servers and accessing resources using SSH keys instead of passwords. We use the SSH-keygen command for the same. This prevents brute force attacks, and we only need to put in a password once. Types of accounts. User accounts. User accounts are individual accounts assigned to specific users. Users authenticate using personal credentials like username or password, or multi-factor authentication. Files of one user cannot be accessed by any other user. And user accounts never have privileged access to the operating system. Shared and generic accounts. These accounts have multiple users, often with a single set of credentials. This can lead to a higher risk of security breaches and are difficult to track individual user actions. It is recommended not to use these kind of accounts. Guest accounts. Guest accounts are temporary accounts provided to an external user. They have restricted access and to only necessary resources and are under the risk of privilege escalation. Service accounts. These accounts are used by applications, services, or automated processes. These accounts also need credentials, and permissions are scoped to only what the service needs to function. Privileged accounts. These are accounts with the highest and level of access and control, and is typically used by administrators. It has more strict security controls and monitoring, such as multi-factor authentication and logging. It is not recommended to use privileged accounts for general use. Account policies. An account policy is a set of rules and procedures for managing user accounts. This involves account creation, account maintenance, and account deactivation. Routine audits. It refers to regular review of user accounts and access controls. They help ensure compliance with policies and identify potential security issues. Password complexity and length. Account policies can enforce the creation of a strong password and prevent brute force attacks and dictionary attacks. It is done by changing complexity, length, and the frequency of the change of password. Account lockout and disablement. Account lockout prevents unauthorized access and protects against brute force attacks, in which case it can lead to either a lockout or disablement. Lockout is a temporary lock on an account put after a specified number of failed login attempts, whereas disablement permanently disables the account. Location and time based policies. These policies restrict account access based on geographic location and the time of day. Access may be restricted to accounts from specific geographic locations or may be allowed only during certain hours. Authentication management. Password keys. Password keys are hardware based devices that provide an additional layer of authentication. These devices are resistant to phishing and other online attacks because the key is required to generate the authentication code. Password vaults. Password vaults are encrypted databases that securely store, generate, and manage passwords. Password vaults automatically fill in login credentials for the websites and applications. Some famous examples are LastPass, OnePassword, and KeePass. Trusted Platform Module or TPM. A TPM is a dedicated microcontroller designed to secure hardware through integrated cryptographic keys on a PC or server. It also supports hardware based encryption and decryption operations. Hardware Security Module or HSM. An HSM is a specialized hardware device designed to protect and manage digital keys and network cryptographic operations for a network. It helps us in key management, encryption and decryption, and signature creation and management. Knowledge Based Authentication or KBA. KBA asks questions based on information that the user knows. It requires users to answer questions that are difficult for others to guess. These questions can be static or dynamic. Static KBA uses preset questions and answers, while dynamic KBA generates questions based on the user data in real time. PAP and CHAP. PAP or Password Authentication Protocol is an authentication method that transmits username and passwords in plain text to a server that verifies the credentials. This protocol is often used as a fallback method when other more secure protocols are not available. Challenged Handshake Authentication Protocol or CHAP. CHAP uses a challenge response mechanism to authenticate the users, that is, a three-way handshake. In this case, the servers send a challenge message when the client calculates the hash from the challenge and the password, which is then verified by the server.